In this lecture, we are going to talk about the p-value and the test based on this p-value. So we have already seen that we have estimated the parameter of the population based on the statistic S of the sample. So the main parameters which we have found is the population mean and the population proportion, or the difference in two populations, or the difference in proportion of the two populations. So next we have also seen on how we can calculate the Z variate associated with the statistic S and the parameters given with respect to the population. So Z is given as S minus mu S divided by sigma S. So let me denote this as Z star. And based on the statistic and the parameters, we have constructed the null hypothesis, wherein the null hypothesis would always be the parameter we want to test to be equals to some constant k, and the alternate hypothesis is the parameter either is less than k, greater than k, or not equals to k. If it is less than k, then this is the left tail test. If it is greater than k, then it is the right tail test, and not equal to k, then it is the two-tailed test. So for the left-tailed test, the alternate hypothesis is the parameter is less than k. Then the p-value is calculated as probability of all z less than or equals to z star. Okay, so in this case z star will be negative, and we know that in a left-tailed test the region of rejection is anything less than minus zc. So if the probability of z is less than z star, so that is your p-value. Then for a right-tailed test, the alternate hypothesis is the parameter is greater than k. In this case, the p-value is given by probability of all z greater than or equals to z star. And here in the two-tailed test, we expect the z star value to be positive. And this is zc for the right-tailed test, and anything above zc we would be rejecting. And the third case is the two-tailed test, wherein the alternate hypothesis is the parameter not equals to k. So in this case, the p-value would be equals to 2 times probability of z greater than or equals to z star if z star is positive, and 2 times probability of z less than or equals to z star if z star is negative. And we know what is the region of rejection for the two-tailed test. So anything beyond zc and anything beyond minus zc will be rejected. And at alpha percent level of significance, or just alpha level of significance, we know that for the left-tailed test, alpha percentage or alpha scores will lie below minus zc. For a right-tailed test, alpha percentage lies above zc, whereas for a two-tailed test, alpha by 2 percentages lie above zc, and alpha by 2 percentages lie below minus zc. So now let us move on to the problems. The first problem is like this. The 9th grade algebra scores in a school district have been normally distributed with mean 75 and standard deviation 8.25. So mean mu is given 75, standard deviation is given 8.25. A new teaching system is introduced to a random sample of 25 students. So n is equals to 25. And in the first year under the new system, the average score is 78.2. So that is the average of the sample, which is x bar is equals to 78.2. They're asking you what is the probability that an average this high would occur for a random sample of 25 students in a given year under the old system. So under the old system, they are asking you what is the probability that average this high would exist. So that is probability of x bar greater than or equals to 78.2 we need to find, or this is probability of z greater than or equals to x bar minus mu divided by sigma divided by root n. So which amounts to be probability of z greater than or equals to 1.94. This is found to be equal to 0.0262. And in the second case, they are asking you state a null hypothesis and alternate hypothesis for testing the new teaching system described. So the null hypothesis would be the population mean is equals to 75. And here the alternate hypothesis will be, so we are expecting anything greater than the usual mean. So mu will be greater than 75. So these are the null hypothesis and the alternate hypothesis. In the third question, they are asking you what is the statistic and the p-value of the test. So we have already found the statistic, that is z. Z is equals to 1.94. And since this is a right tail test, we are going to find probability of z greater than or equals to 1.95, and this we have already found it, that is 0.0262. Next, come to the fourth question. At which significance level would the null hypothesis be rejected? So we are going to compare the p-value. We are going to compare the p-value with what is the percentage of significance. So here, since they have not mentioned it, we will consider at both the levels. So p-value we are going to compare with 0.05, and we are going to compare the p-value with 0.01. So we want to see whether it is less than. So if it is less than, then we are going to reject the hypothesis. If not, we are going to accept the hypothesis. So here you see that 0.02 is certainly less than 0.05. So we are going to reject the hypothesis at 0.05 level of significance, and here the p-value, it is not less than 0.01. So we do not reject the hypothesis. We will not reject the hypothesis at 0.01 level of significance. Next, fifth question. What is the critical region for the test at 0.05 and 0.01 level of significance? So this is a right-tailed test at 0.05 level of significance. We know that ZC is equals to 1.65, and they're asking you the critical region. So the critical region for the right-tailed test will be anything greater than ZC. So the critical region is 1.65 to infinity. And at 0.01 level of significance, ZC is equals to 2.33. The critical region will be anything greater than 2.33, that is 2.33 up to infinity. Next, the sixth question. For what values of the sample mean x bar will the test statistic lie in the critical region? Will the test statistic lie in the critical region? That means for all z greater than or equals to 1.65 at 0.05 level of significance, it will be lying in the critical region, or x bar minus mu, which is 75 over 8.25 divided by root 25 is greater than or equals to 1.65. So this will fetch us x bar to be greater than or equals to 77.72, and at 0.01 level of significance, we expect z to be greater than or equals to 2.33 33, then it will be lying in the critical region, or x bar minus 75 over 8.25 over root 25 to be greater than or equals to 2.33. So this gives us x bar greater than or equals to 78.84. So this was all about the first problem. Let's move on to the next problem. The useful lifetime of Everlast 1.5 volt battery is normally distributed with mean 400 hours. So mu is equals to 40 hours, and standard deviation of 4 hours. Sigma is 4 hours. A new chemical composition is introduced to make the production of the batteries more efficient. The company wants to see if the useful life of the battery has been affected by the new process. They want to see it is affected, it is improved or it is deteriorated. They don't want to see it is just affected. Specifically, they wish to test the null hypothesis H naught as mu is equals to 40 against the alternate hypothesis HA is equal to mu naught equals to 40. So H naught is mu equals to 40 and HA is mu naught equals to 40. So this is the two-tailed test. It is assumed that the standard deviation is still 4 hours. A sample of 100 batteries, that is n is equals to 100, has a useful lifetime of 39.1 hours. So that is the sample mean. X bar is 39.1 hours. In the first question, they are asking us to determine the test statistic and the p-value of the test. Okay, so that means we need to find the z. So z will be equals to x bar 39.1 minus mu, which is 40, over sigma divided by root n. Root n, what is it? N is 100. So yeah, n is 100. Root 10. So this gives us minus 2.25. And then they're asking you what is the p-value of the test. Since it is a two-tailed test, we are going to, and this is negative, so we'll be finding 2 times probability of z less than or equals to minus 2.25, and that is found to be equals to 0.0244. Okay, next question. At which significance level would the null hypothesis be rejected? So here we are going to use the p test. Okay, so your p value, which is equals to 0.0244, we do want to see whether this is less than 0.05. Of course, this is less than 0.05. So we are going to reject the hypothesis at 0.0 level or 0.5 level of significance, and the p value is p value, which is 0.0244. We want to check whether this is less than 0.01. No, it is not. So we are going to accept the hypothesis or do not reject the, we do not reject the hypothesis at the 0.01 level of significance. Next, the third question. What is the critical region for the tested 0.05 and 0.01 level of significance? So this is the, the two-tailed test, right? So at 0.05, the critical value is ZC is equals to 1.96. They're asking you the critical region, that is the region of rejection. So the critical region will be, region of acceptance will be minus 1.96 to 1.96. So the region of rejection will be minus infinity to minus 1.96 and 1.96 to infinity. And at 0.01 level of significance, ZC is equals to 2.58. The critical region will be minus infinity to minus 2.58 and 2.58 to infinity. So that was about the third question. So next, what they're asking you, use the critical regions obtained to determine whether to reject or not reject the null hypothesis. Okay, so Z we obtained to be equals to minus 2.25, and so this is the critical region 1, this is the critical region 2, So we do want to check whether this belongs to the critical region 1. Yes, of course it belongs to the critical region. So therefore we are going to reject the null hypothesis at 0.05 level of significance, and minus 2.25 we do want to check whether this belongs to the critical region 2. 2.25 certainly it is not belonging to the critical region, so therefore we are do not reject the hypothesis, do not reject at 0.01 level of significance. Okay, next, the fifth question: for what value of the sample mean x bar will the z score of x bar lie in the critical region at 0.05 and 0.01 level of significance? So again we expect z to be for this is a two-tailed test, so we expect z to be greater than or equals to 1.96 and z to be less than or equals to minus 1.96 at 0.05 level of significance. Or in other words, I would say that x bar minus 40 divided by 4 divided by root 100, I think I will get it as 0.4. We expect this to be greater than or equals to 1.96, or x bar minus 40 over 0.4 to be less than or equals to minus 1.96. So solving this, we will get that x bar would be greater than or equals to 40.78, or x bar to be less than or equal to 39.22. So that the lie in the z will lie in the critical region at 0.05 level of significance, and at 0.01 level of significance we expect z to be 2.5 greater than 2.58, or z to be less than or equals to minus 2.58 to be say that the critical z value lies in the critical region. So greater than 2.58, or x bar minus 40 over 0.4 less than or equals to minus 2.58, and this is implying x bar is greater than or equals to 41.03, or x bar is less than or equal to 38.97. Okay, so this was all about the p value and on how we are going to reject the null hypothesis based on the p value.